It's not a deadly spider, it's a huntsman.
Yeah, scary stuff. Yeah, I won't show you that. Ouch! God damn it.
We flick our magic switch on. Oh! Hi folks, welcome to another episode of The Art of Engineering. And in today's episode, we are going to do the magic switch. And what is the magic switch? The magic switch is part of Project 160. In fact, it's part 2 of Project 160, which was, part 1 was getting me on air. And at the moment, I can now run FD8 via my Hermes Lite. And I can also do CW via my QRP Labs QCX Plus. So we're okay for part 1. We can get on the air. As you can see, this is my very, very modest backyard. And it's this piece of grass I'm standing on here is about 10 by 10 meters square, just big enough to put down a loop on the ground, which you've seen in a previous video. The biggest antenna I can put on this lot, wire antenna, is an end-fed half wave for 80 meters. So that is half the size I need for 160 meters. What if I had a magic switch and I could flick the switch and it would make this block of land double the size? And then I could put up a half wavelength at 160 meters. Like those Feng Shui people do, I could make a giant mirror and make the antenna think the yard is twice the size. Well, that's kind of what the magic switch is going to do. I'll quickly show you the antennas on the lot, and then we'll jump inside and we'll see how the magic switch actually works. See here, this is my vertical L antenna. It's built for 20 meters, and if you look up the top there, you can see there's a little trap there, a loading coil. That makes the antenna resonant on 40 meters. So I can do 40 and 20 on this antenna. And in the background there, with a very new squid pole that I just put up, the antenna used to slope down to this pole over here in an inverted V fashion. I've now made it virtually a horizontal L antenna, because it goes up 10 meters to the top of the squid pole, which gets it mostly out of the tree and higher above this tin roof. And then it runs across here, and it's now a lot higher than it used to be, up to the top of the squid pole that is strapped to the chimney, and then down to the front of the house. But wouldn't it be great if we could see this from the air? Now, during the installation of this new system, a lot of antenna wear and tear was indicated to me, and I was very happy about that, because had I operated into this thing with all the damage that was there, I probably would have done some damage had I not been vigilant of SWRs and whatnot, which I'm notorious of not paying attention to. And we're on the roof, and that's where we're going to go to have a look at how the magic happens. And you can see there's a ground plane that we've had to install. We've got this lovely metal roof, which works against me a lot of the time. But when you're talking about for counterpoises, like this is the counterpoise for the vertical L I showed you, or for this antenna that I've just built, what better earth plane can you have than a metal surface? You know, you take what works against you sometimes and you make it work in your favor. And this is where the magic happens. This is the box that lets the magic switch work. So it's the magic box. It's my second magic box. I've got my magic antenna switching box as well. And this is where the relay lives. So the ground now comes off the switching box, and we have our antenna coming in on one side, and from here we go up to the unan. So it's just one extra piece of equipment that sits between the unan and the feed line, and that's what allows this antenna to be an end-fed half wave at 80 meters. But when you switch the switch on, it becomes a quarter wave at 160 meters, and the other quarter wave, which you need to make a half wave, is this beautiful ground plane. I don't know how many radials I've got, and I wasn't very precise about the length of them. I just laid out as many as I thought I could, and I probably will lay out some more when I get a chance. As luck would have it, I had to rebuild the Annan. You probably saw the short video at the beginning about what happened with that, but I'll explain a little bit more about that because that was quite surprising what damage those ants did. And that is a new squid pole, which used to be my portable antenna squid pole. I'll have to buy another one for that. I have made this antenna so much better, so much higher, and I am a happy chappy. Now, I'd like to say that this whole process was flawless and we didn't have any issues, but I'm going to tell you about some of the issues I had. The power supply stopped working, and I thought I'd shorted it out when I was running the cabling up because I didn't have a fuse in the line. Although it's got protection on it, so I thought maybe I'd blown the Zener diode protection, etc., etc. What happened was a completely unrelated problem. My switch that I had on that supply, I actually tried to super glue it in because I made the hole a little bit big anyway. It was a real botch job, and then the actual switch got super glued so it wouldn't work, and then I had to bash it, and eventually it did work, but it was always a bit dodgy. So the switch has finally failed. At the moment, I'm bypassing the switch and I'm just switching it on at the wall. And then I bought the wrong relay. I got a 24 volt relay, although it was in the 12 volt bin. It was in the wrong place. It looked just like the 12 volt ones. And so I had the wrong relay. So that slowed me down. So I actually put in a 12 volt, very small mini relay, thinking, well, I'll just use it as proof of concept and later I'll change it. And that relay failed. And it failed probably because at the end of the antenna, when you're using it as an end-fed half wave, you've got massive voltages. Even 5 watts QRP, you'll have kilovolts at the end of that antenna. And because the relay was very, very small and the contacts were probably very, very close together, I am making the assumption that it was arcing out. So that relay was toast. It was causing all sorts of problems. So that failure happened. And then the Annan failed, but basically the Annan had ants in it. And you think, well, you know, how much damage can ants do? Well, I couldn't find the actual main conductor that goes from the Annan to the antenna. It had completely disappeared. And I'm thinking, am I losing my mind? Because it was working for 1 second and now it's not working well. My mate Chris actually pointed out that the ants quite often produce formic acid, and that acid has probably eaten through the metal of the main conductor. So it was probably there as like a honeycomb, and eventually it's just failed. Complete failure of the antenna, which was good because the original Annan, 49:1 Annan I built, was actually made from 2 cores because I wanted to make it quite high power, and probably overkill. And one core was the 240/43 correct formula for an Annan, and the other one was for a common mode choke. Very different uses. One was to suppress RF and one was to change impedance, and I had them stacked together. So that core was probably losing me a lot of signals. So it's good that the Annan failed because it gave me the opportunity to rip out the old core and actually put in the correct toroid and get it all wired correctly and get rid of all the rusty bits and pieces and whatnot. So we have a brand new Annan up there, which I'm very happy about also. And like I was showing you, the new squid pole, we're higher, we're better. So every time you go up there, it's an opportunity to make things better. I also managed to blow the finals in the QCX Plus. I had the magic switch switched off instead of on, and I was transmitting and I didn't look at the SWR, and before I knew it, 3 BS170 FETs, dead. Luckily, when I was building the QDX, I thought I'd blown the finals in it. It was actually a setup issue that I had. So I ordered some transistors. So I had the transistors on hand, popped them in, and it's back to normal again. So really happy about that. Let's get back to the video. So we have got our supply on and the magic antenna box is on because we're going through the magic antenna box because this is what the transceiver is actually seeing. And this is my end-fed half wave, which is selected on antenna 1. If I go to 2, I go to the vertical L, and you'll see we ain't resonant on 80 meters. But on antenna 1, this is set to 3.520, and it's a beautiful SWR of 1:1.08. And I can operate straight into that barefoot, no problem at all, no tuner. It's a lovely antenna for 80 meters. You can see that at the moment we're scanning 1 to 5. If I was to try to operate on 1.8, I'd be losing my finals because there's no way I can operate with that high in SWR. And my AT230 will not tune this antenna on as an end-fed halfway for 80 meters. It will not tune it to 1.8 megs. So what's a man to do? Well, if you've got one of these in your shack, the problem is solved. It's called the magic switch. So what we do is we flick our magic switch on, and let's have a look at what's happening on the Nano now. Oh, and that's at 1.8 there. It's 1.8. At 1.8, it's 1 is to 2.25. I would prefer to have it under 2. I have fiddled with it. I could probably add more radials to the ground plane and get it right where I want it. I can flick this to 1.5 and tune this no problem at all. In fact, I'll show you that right now. And there you have it, folks. That is 1.8 megs tuned to 1 is to 1.62. Very sharp tune, but it tunes it very nicely. And even with the thing on without the tuner, it's below 3 and slightly above 2. I don't know if I trust the finals for the QCX on that. The Hermes Lite has a bit of SWR protection. It hasn't got an issue with it. Nice cup of coffee. And we have been to J-Car. I got relays, but I wanted to get something a little bit more heavy duty. This is for switching the un out, or bypassing the un. That's going to be done remotely at the antenna, so we don't have to constantly climb on the roof if we want to implement a 160 meter antenna. And I also went and got some BNC connectors from J-Car. Not the cheapest place to go to buy parts, but the convenience factor is always nice. So I'm going to make up a lead so that we can go from the un box to the bypass box and then down to the shack. The other thing that's going to need to happen is, the test bench. I've got my meter over here, and I constantly have to go into the console and steal cables out of that. I'm sick of doing that. So I'm going to make some extra leads so that when I'm playing around with QRP gear on the test bench, I've got the cables that I require. I've got to say, school holidays are great. What a difference a couple of hours in the shack can make. This is the shorter one that I'm going to use to implement this change to the antenna to bypass my 49 to 1 un and make this antenna resonant on 160 meters. These extra leads here are going to be for, one of them is going to connect my receiver, my chocolate box receiver, to my Mooncake transmitter, and the other two are going to go on the back of the meter over here for testing on the test bench when I'm building QRP transmitters and transceivers. Time for continuity. I have the probes going into the through. So this goes through to the 49 to 1 unknown when the antenna is going to be an end-fed half wave. We've got a proper relay in there now, which is nice. When we switch off, we lose continuity from here to here because that's going through to the 49 to 1 unknown. Hopefully, we have continuity going through to the antenna wire now, which we do. And let's just see if we lose continuity when we switch the meter off. So there's our continuity. We've got to keep it in there. And then we switch the magic antenna switch off. And it stops screaming. So we know the box is doing what it should. We should also lose continuity between the earths when we switch the box on, because we don't want that going through. And that's also working. So I'm a happy chappy. I don't want to make things too confusing, but it's good to have a little bit of knowledge about what's happening in antennas. And this is the distribution of voltage and current. Don't get too frightened by this. Basically what it's telling you is when the current gets to the end of the antenna, it's got nowhere to go, so it goes down to 0. That's a nice way of remembering it. I don't know if that's actually what's happening, but that's, if you're looking at a half wavelength, lambda on 2, so at 80 meters, each time your radio wave leaves the antenna, it's going to be 80 meters long, 300 over the frequency in megahertz. And that will give you a 40-meter antenna that you require if you want to have it resonant, unless you load it up and do all the sort of fancy stuff you need to do for a non-resonant length. But keep things simple. We need 40 meters for a half wavelength at 80 meters. So this is what it looks like. We're feeding it at the end in this installation here, and that means we're using a 49:1 transformation. So at the center, the impedance is going to vary depending on the height of the antenna, but we say it's nominally about 50 ohms. And at the end of the antenna, we're looking at about 2,500 ohms. And that's why we need a 49:1 unbalanced to unbalanced un. And that makes your high impedance of 2,550 ohms for your coax that you're feeding it with. So that's what I'm dealing with here for 80 meters. Now, we know it's low at the center and high at the end because basic Ohm's law, voltage over current. Because you've got a high voltage and a low current, you're going to have a very high impedance here, or resistance if you want to think of it that way. And at the center here, you're going to have a low impedance because your voltage is almost zero over a large current. That makes a very low impedance. So that's how the voltages and the currents are distributed on your half wavelength. So my 80-meter antenna looks like that. I cannot use this antenna for 160 meters. It needs to be double the length. So what we've done is we've built a circuit that bypasses this 49:1 un, and that means we're now feeding it at the center, kind of like your vertical antenna that has reflection in the ground. So this half of the antenna is our original 40 meters that we use for the half wavelength at 80 meters. We've bypassed our un, so we're effectively feeding the antenna at the center, and this dotted line on this side is our earth plane. So it's like a reflection of the main element. And that is why if we want this antenna to work well, we have to try and get an effective ground plane happening. And that's why I've run the radials. More radials is going to be better, up to a certain amount. There's a whole lot of theory and science associated with that, but don't get too technical about it. Run as many as you can, and that will improve your antenna efficiency. So that is what's happening in a nutshell. If you have any questions or comments, please do so below. Now, I promised you the circuit, and I always like to give credit where credit is due. And I could easily show you this circuit, but that would be a disservice to this gentleman here, Steve Ellington, November 4 Lima, Quebec. And he has come up with both a bypass solution for an end-fed half wave that doesn't involve a relay. You just plug it in. So if you've got access to the antenna easily, you can just do it that way, or you can do it with this solution here. I will put a link in the video description below so you can access it. And on the video over here, as you enter the video, he gives you a circuit diagram, and all will be revealed as to how that all works. Very simple circuit. Watch the whole video, you'll learn a lot. Send out a single whisper transmission. It's 2 minutes, and just to see what's going on. It's just getting dark here in Sydney, and I was heard by a Victorian station on whisper and a South Australian station on about 3.5, 4 watts, which is what the Hermes is putting out on 160 meters. And this is a Sydney to Forster SDR, 300 odd kilometers. This is the SDR online radio in South Australia at Tarlee. It's got a great signal to noise ratio. I don't know if you're going to be able to hear this, but I can actually hear my signal just coming through. I'm just going to turn off the side tone. Well, that's the final installment of Project 160. I will let you know if I have any success with any QSOs on the 160 meter band. Always like to share all of that stuff. The jury's out as to how effective an antenna this is, but it was always going to be a compromise. It's just great that I can now get on 160 meters, and I now have an antenna that if I do build any loaded verticals, I can compare this antenna to the new one that I build and see if it's better or if it's worse. Thanks for sticking around right to the end of the video, and I will see you in the next episode. of the Art of Engineering. 73.